Let's consider one more example for constructing DFA. Given language L3 with strings ABA, BAB, BBA over an input alphabet sigma equal to A comma B. We need to construct a DFA to accept this language. Any DFA starts with an initial state to process the input string. Let's consider this as our first input string ABA. So from the initial state, let's say Q1 is our initial state. On seeing symbol A, we go to Q2. On seeing symbol B, we go to Q3. On seeing symbol A again, we go to Q4, which is our final state, because we need to accept this string. Now consider the second string BAB. On seeing B from Q1, we need to go to some other state. So let's say this is Q5. On seeing A from Q5, we go to Q6. On seeing B from Q6, the third symbol, we have to accept the string. So we go to the final state. Now second string is also done. Now let's look at the third string BBA. From initial state, on seeing B, we already have a transition. So it goes to Q5. From Q5, if we see B, we go to Q3. On seeing B, we go to Q3, because on seeing A, there is already a transition leading to a final state from Q3. So we can directly join Q5 and Q3 by seeing B. So on seeing B from Q5, we go to Q3, and on seeing A from Q3, we go to Q4, which is a final state. So BAB is accepted. Now let's look at each state and check whether it has transition over every input symbol. Starting with initial state, we can see that Q1 has transition over A and B. So Q1 is complete. Now coming to Q2. Q2 doesn't have a transition over symbol A. So how did we reach Q2? On seeing symbol A. So after seeing A, if we see one more A from Q2, we have to reject this string AA, because this is not in our language. This is not in our language. So we need to reject this. So if we see an A from Q2, we go to dead state. We need to reject that state. QD is our dead state, let's say. Now Q2 has transition over A and transition over B. So Q2 is complete. Now come to Q3. Q3 has a transition over A, but it doesn't have a transition over B. So how did we reach Q3? By seeing AB in this way or BB in this way. So we reached Q3 by looking either at AB or BB. So at Q3, if we see A, we accept it. What if we see B instead of A after AB? I mean, what if we have a string like ABB? So we reached Q3 after seeing AB. Now if we see B, we need to reject this string because this is not in language L3. If we see B from Q3, we go to dead state. Now Q3 is complete because it has transition over A and B also. Now come to Q4. We see that Q4 doesn't have a transition over A and B. How did we reach Q4? By seeing ABA or BAB or BBA. So after ABA, if we see an A, we need to reject this string. So from Q4 on seeing A, we go to dead state. If we see B instead of A here, that is ABAB, which is not in our language, we need to reject this string. So if we see B from Q4, we go to dead state. Now Q4 has transition over A and B, so Q4 is complete. Now Q5 already has transition over A and B, so Q5 is complete. Come to Q6. How did we reach Q6? We reached Q6 by seeing BA. If we see B, we accept it because BAB is in our language. What if we see A, that is BAA? For BAA, the string BAA is not in our language, so we need to reject this string. On seeing A from Q6, we go to dead state. Now Q6 is also complete. We are left with QD. QD is our dead state. So whatever symbol if you see on dead state, we will be rejecting that and we will be in the dead state itself. So A comma B. So the transitions over A and B goes to QD from QD itself. So this is our DFA for L3. The languages which we have seen till now, like L1, L2, L3, all these three, if you observe, all these three has finite number of strings in the language. Like here L3 has three strings, L2 has 3 strings, L1 is also having 3 strings. So all these are finite. So we can say that these languages are finite languages. Every finite language is a regular language. We can say a language is regular if we are able to draw a DFA or we can express the language in a regular expression. We will see what is regular expression and how do we convert from DFA to regular expression and regular expression to DFA in the later videos. Similar to finite languages, we also have infinite languages. For which we cannot guarantee whether a DFA exists or not. Now let's look at the classification of languages based on the number of strings in the language.